Hey guys, just want to go through this worksheet to try and help you explain and understand friction a little bit better. So hopefully through this you can understand. So for question 1, I have 100 Newton box at rest on a tabletop. We'll just draw that, 100 newtons. That means that my normal force and my force of gravity cancel each other out, and my normal force and force of gravity both are 100 newtons. And I know that I'm going to be pushing it westward. We'll just say right is the west direction, because we can say that, of 35 newtons. So that's going to be an applied force. What I do is when I see these numbers, coefficients of friction, I calculate what those are. The static friction force ranges between 0 and mu times mu static times normal force. What that means is the force of friction, no matter what it is, this backwards FFS, if it's not moving, will push exactly as hard as I'm pushing up to this value. And this value is in this case, 0.4 times 100, which is 40 newtons. So my static friction force can range anywhere from 0 to, force of static friction, to 40 newtons. As soon as I get above 40 newtons, I'm no longer in the static friction force. If F applied greater than 40 newtons, my friction force is my kinetic friction force. And whatever the applied force is, I only have to beat my kinetic friction force, which in this case, and is always 0.3 times the normal force, which is 30 newtons. So until I push hard enough that I'm at 40 newtons, or above 40 newtons, I can't move anywhere. And this question is saying I'm only pushing 35, which means I'm not above yet my 40, I'm still within this range. I haven't reached 40 yet, so I'm in the static friction range. Because I'm in the static friction range and I haven't pushed yet 40, I get matched. My force of static friction matches my applied force. So another way to say this, if FAPP is less than, in this case, 40 newtons, then the force of static friction, FFS, equals my applied force. So my applied force is 35 newtons to the right, which means my force of static friction has to be 30 newtons eastward, because it said it was westward. Eastward. Not 30, I'm sorry. Not 30, 35. It matches 35 newtons. 35 push to the right, friction counteracts me, 35 back, because I haven't broken the bonds yet. So hopefully that helps with question 1. Question 2. Question 2 says, a 30 kilogram crate is at rest on a factory floor. Coefficients are blah blah blah. What force will it take to get the crate moving, and how much force does it take to keep it moving at constant speed? So to get the crate moving, I have to match and really just be just a slight bit above the static friction force. And the max static friction force, FFS, is equal to my mu s times my normal force. My normal force is equal to my gravity, and my gravity, my force of gravity, is m times g. The reason I have to do it this way is because I'm given a mass, not a weight. So my static friction coefficient is 0.3, my mass is 30, and my g is 9.8. So I do that in my calculator, 0.3 times 30 times 9.8, I get 88.2 newtons. This means that in order to keep in order to get this thing moving, my FAPP, my applied force, has to be greater than 88.2 newtons. That's part A. Part B is asking, once it is moving, what force do I have to keep it moving at constant speed? Well, at constant speed, my F net is 0, which means that my force applied has to equal my force now, because it's moving, my force of kinetic friction, which allows me to say that my force of kinetic friction is always that same value. It's the coefficient of kinetic friction, mu k, times 30 times 9.8. 0.1 times 30 times 9.8, 29.4. So to keep it moving at a constant speed, my applied force has to match what the kinetic friction force is, and that would be 29.4 newtons. Okay, moving on to question 3. Moving right along, doing well. 400 Newton wagon, that is my weight, is at rest on a carpeted floor. Coefficients, blah, blah, blah. What will happen if you push horizontally with 245 newtons? And then what will be the acceleration of the wagon? So again, I have to figure out whether this is moving or not. Am I in the static range or am I in the kinetic range? To do that, I have to, once again, find my static friction force and my kinetic friction force. My static friction force is 0.6 times the weight, so 0.6 times 400, which is 240. And while I'm on that same topic, I might as well do the 0.4 times 400, which is 160. Alright, so my static friction force is 240, but I'm pushing with 245. When FAPP is greater than, really when it's greater than mu s times the normal force, which in this case is 240, I get movement. And I'm no longer in kinetic friction. I'm no longer in static friction, I'm in kinetic friction. So what this allows is me to say, what happens if I push horizontally? Well, I move. Or it moves. The wagon moves. I've broken the bond of friction. I'm beyond it. I've pushed hard enough to get it started. Once it started moving, I don't have to push as hard to keep it moving. So that's where part B comes in. Part B says, what is the acceleration of the wagon? Well, we set up a simple free body diagram. I have 400 newtons up. That's my normal force. My force of gravity is also 400 newtons. They counteract each other. I have an applied force of 245. That hasn't changed. At least the problem didn't say it changed. But since I'm moving, I don't use this anymore. I use this number. I don't have the 240. I know I'm above it, so I'm already moving. So my force of kinetic friction, and you got to be specific when you label it, FFK, is 160. So my net force, my vertical is done. My net force horizontal is 245 minus 160, which is 85 newtons. But I'm trying to find my acceleration. And acceleration is really acceleration in the horizontal direction. It's the only one we have. Is net force over mass. Well, my mass I can find from this, because that is, just write it down here, Fg equals m times g. So m is my 400 over 9.8. 400 over 9.8 is 40.86. My acceleration is kilograms. My acceleration is 85 over 40.86, 2.08 meters per second squared. Whatever direction it's moving. So in this case, you could just say horizontally. So because I push harder than the static friction force can push back, I get movement. Because I'm moving, my friction force jumps to a kinetic friction force, which I then set up the free body diagram and solve it just like we've been solving it. Perfect. Okay, question 4. Moving right along. This will probably be the last one on this video, and then we'll do another video for 5 and 6. We'll see. We have a 10-kilogram block of ice sliding across the kitchen floor. If the coefficients of friction between the ice are 0.2 static, 0.1 kinetic, how much friction is acting on the ice? what will be the acceleration of the ice? Key word here is this one right here. Sliding. Sliding tells me I'm moving. Moving friction is kinetic friction. So kinetic friction is my 0.1, my kinetic coefficient, times, going back to question 2, mass, which is 10. When I have mass, I have to multiply by 9.8. So 0.1 times 10, well, that's just 1, times 9.8 is 9.8 newtons. So my kinetic friction force is 9.8 newtons. And because I'm moving, that's how much friction is acting on the ice. Part B says, what will be the acceleration of the ice block? Well, it doesn't say anything about an applied force, so my applied force is 0, and that's okay. This block of ice is moving in this direction. That's its velocity. That's not a free body diagram. So it's moving in that direction, but the only force that's acting on it is backwards, because friction's trying to slow it down. FFK, 9.8 newtons. So what's happening is I'm just slowing down. My net force is negative 9.8 newtons. My mass is 10 kilograms. My acceleration, which is net force over mass, gives me, I don't have to do that in the calculator, negative 0.98 meters per second squared. Negative 0.98 meters per second squared, this negative means slowing down. So my acceleration is if it's moving to the right, I could say it's 0.98 meters per second squared to the left. Or the reason I can say that is I drew it to the right, which means it's slowing down to the left. It's tricky when you don't have certain things. You have to assume and make these inferences. I assumed that my my applied force is 0 because it doesn't mention anything about it. If it doesn't mention it, you can assume that. So hopefully 1 through 4 have helped. Look on for the next video coming up shortly for questions 5 and 6.